All right. So this constant is the ionization constant of water. It stays the same. It's a number. It's like pi, or it's like, Avogadro's number. It doesn't change. It's going to stay the same every time. Okay. So we did a few examples yesterday. If you weren't here, you can go back and watch the video from yesterday. It is online. We're going to talk about the next couple of equations. So my goal today is to get through these next two equations with practice and then show you the last three, because even though it says 6 equations, guys, take a look at your gold card that I gave you.
Only 3.
There's really only 3, okay? And what I mean by that is the other 3, to make it 6, are the opposite, all right? The opposite ion, but the math is going to be the same. We'll see that as we get there. So take a look. You do need calculators, so if you don't have one, get up and grab one. Guys, our second equation, this is that pH one. pH equals the negative log. Now, yes, we're using logs. Have you guys done logs in math class?
Yes.
Right? Fun times, right? Guys, good news here. This is base 10. Calculator does all the work for you. You don't have to worry about figuring out and doing all the craziness with the logs. It's simple. Big thing I want to point out, though, is if, like yesterday, all right, when you have something that's like 1 times 10 to some power, 10 to the negative 4th, we'll say, okay, as long as it's a 1 out in front, you don't even need to plug it into the calculator. Okay? If it's a 1 out in front as your kind of, it's not your base, but it's your scientific number there, it's just whatever the exponent is except positive. So if you take the negative log of something like this, 1 times 10 to the minus 4, it's just 4. So whatever it is, like here, the examples that I show you, 10 to the negative 7, that's like saying 1 times 10 to the negative 7. So if I just give you a 10 to some power, you're assuming that it's a 1 out in front. It's just the positive of that exponent. So 10 to the negative 3, it's just negative 3. I'm sorry, that actually should be 3 right here. If it's like 10 to the 3rd, it would just be negative 3. All right, it's negative whatever the exponent is when you do the log. Now, we're never going to see a negative pH value, so this wouldn't be one that we would look at. It would just be like log of 10 to the negative 3, which would make it 3. So when you have just 10 raised to a power and you take the log, it's just that exponent except positive. And then if it's 1 times that, same thing. It's when you don't have a 1 out there, because this is base 10, we can do that. When you don't have a 1 out in front, that's when you actually have to go to the calculator. All right, so it's just kind of a quick thing. When in doubt, always go to the calculator. The calculator's not going to steer you wrong, as long as you plug it in correctly. So let's take a look at an example, guys. What's the first thing we have to do? Okay, we got to find the concentration of the hydrogen, or really, though, to get that, we have to identify what first? All right. The answer's already there for you, right? Yeah, so ignore those answers. But guys, even before we start doing anything, we have to identify if I have a what? An acid or a base. That's the first thing. What do I have right here? Base. So guys, a base produces what ion? Hydroxide. So with this base that we have, are we going to be able to find pH if we just take that concentration? No, because what is pH? pH equals the negative log of what? The hydrogen ion concentration. Okay? So this value right here, this 0.001, is the hydroxide concentration, right? Because we have a base. So this is where it gets confusing, because you can't just assume that you have an acid every time. This is where you've got to use all the 6 equations that we're going to get to. So right now, how do we go from this concentration to get the hydrogen ion concentration? We have to use what formula? The first one from yesterday, that KW. So guys, we have to go through an extra step. This is where you're going to see, as we get through the end of today and into tomorrow, that there's 2 paths that you'll be able to take. So stick with me here, all right? If this way confuses you, there's an easier way coming. If you think this way's easy, hey, that's great, all right? This might be the way you want to use. This is the first one you learn. Maybe not. Maybe you'll want to use something else. Okay? So H plus ion concentration equals, how do I set my formula up now? Look back at your notes from yesterday.
1 times 14
over the OH concentration. Now, before I just plug in my number here, what's the next step after I make sure that it's an acid or a base? What else do I have to look at?
Whether Because there's 2 or 1.
Right, how many ions that solution's going to make. How many hydroxide ions, guys, is this sodium hydroxide solution going to bring to the table? 1, right? Because if we were to put parentheses, there's only a 1 right there on the outside. So for every 1 mole of sodium hydroxide, we get 1 mole of hydroxide ions. So that is, this 0.001 is, in turn, our concentration for hydroxide. So we'll put that on the bottom. Okay? So do the math. 1e negative 14 divided by 0.001 is going to give me my hydrogen ion concentration. If you were absent yesterday, you're going to definitely want to go and watch the video from yesterday. Okay? What do we get? 1 times 10 to the minus 11 molar. So there's our concentration. Am I done with this problem? No, I don't have a pH yet. So I did all that work, guys, just to get my hydrogen ion concentration because I have a base. So I had to go from hydroxide to hydrogen ion. Now I can get my pH. So pH equals the negative log of that value, 1 times 10 to the minus 13. Do I even need to use my calculator? No, I don't, because it's a 1 out in front. But guys, do it. I want you to do it to see that I'm not just, blowing smoke here. Oh, it's to the 11th? I'm sorry.
You said 11 and then 13.
My bad. I was going to say, that doesn't look like it's going to match what I was knowing to be the answer. All right. What's my pH going to be here? 11. Go through, guys, and actually practice the negative log. Then all you have to do is type that number in. 1e negative 11. There's your pH. So how many steps was it for us to get to pH there? 2. Okay, we had to use 2 different equations. We had to use the Kw equation, and then we used the pH. That's the hardest part about these guys. Once we introduce all the different formulas, you've got to find the path to get to where you want to get to. Sometimes it'll be 1 step. Sometimes it'll be 2. Depending on the method you go, maybe it'll be 3 steps. And you'll see what I mean as we get rolling here. All right? I want you guys to try example number 3. All right? Try example number 3 that's in your notes. Do your best with it. Ignore the answer for right now. Make sure that your answer matches that answer in your packet. Sort of. So, first things first, what do I have to look at, guys?
H2.
Which means what? Okay, that's the second step. What's the first thing I got to do, guys, every time? I'm going to keep driving this home. Is it an acid or base? That's the first question you need to ask yourself. What do I have here? Acid, right? Why? Because I see H out in front. What acid is this? Sulfuric acid. All right? Then, so this tells me, hey, this concentration is my hydrogen ion concentration. Or does it? Why, Maddie, do I have to multiply it by 2? Because there's 2 H's, absolutely. So the first thing, guys, is it an acid or base? Then you're looking to see, are there multiple ionizable ions, meaning either hydroxide or hydrogen? We have 2 here. So we're going to take 3.4 times 10 to the minus 3rd. We're going to multiply it by 2 because we have 2 hydrogens. So really, our concentration for every 1 mole of sulfuric acid, what's our concentration for hydrogen ions? 6.8 times 10 to the minus 3rd. Now, guys, I want to drive this home. What I'm saying is very common. We have 1 mole of H₂SO₂. Okay, this is the concentration, all right, when we have just one of these. But when we look at the terms of particles, right, hydrogen ions, for every 1 mole of H₂SO₄, there's 2 moles of hydrogens because of that subscript 2. Just like there's 4 moles of oxygen atoms that would be there if we broke it all apart, there's 2 moles of hydrogen atoms if we broke it apart. That's why we're multiplying by 2, because there's twice as many protons in 1 mole of sulfuric acid. So that's why we had to multiply this. Now, like Tony was saying, it's a 1-step problem because we're looking for pH. pH equals the negative log of the hydrogen ion concentration. So pH is going to equal the negative log of 6.8 times 10 to the minus 3rd. pH is going to equal, now this is one you can't do in your head because it's not a 1 times something, so it's not -3. Maybe close to it, or I'm sorry, 3. Might be close to 3, but what is the actual value when you plug it in? Right, so 2 decimal places, guys, is a good rule of thumb to go to with pH. So 2.16, and there's no unit because it is pH. Questions? How'd we do? Let me see thumbs. If you were there, kind of on the right track, no idea whatsoever. If you weren't here yesterday, all right, that's probably the reason why, and that's okay. Okay, we're going to keep working through it. What's that? You've been taught? Well, that's good. All right. Try this one. Just kind of going through this. We have a base, all right, with 2 hydroxide ions. So what do I have to do? This is now going to be 2.0 times 10 to the minus 4th is my concentration for hydroxide. Well, I'm looking for pH, but pH from our formula says the negative log of the hydrogen ion concentration. Well, I've got hydroxide. That doesn't do me any good. So I've got to find my hydrogen ion concentration. So 1 times 10 to the minus 14 over the concentration of hydroxide. Now this I can't do in my head. What do you guys get for your hydrogen ion concentration? What did you say? 5 times 10 to the minus 11. Then we'll use that to plug in to our pH formula. 5 times 10 to the minus 11. What do I get then for my pH? Right, and let's ask ourselves, does that kind of make sense? I have a base. Is that a basic pH? Absolutely, because what's a base, guys, in terms of pH? Greater than 7. Acids are less than 7. So you know you're in the ballpark. Okay, and again, the more work you show me, the more partial credit I can potentially give to you. So that's equation 2, guys. Now, equation 3 we're going to move right into today. This is just the opposite of what we just did. All right, so we took the log of a number. Now we're going to take sort of the anti-log. All right, the inverse log is really what it is, not anti-log. And what that is it looks like this. The hydrogen ion. So if we are given pH, we can now solve for the hydrogen ion concentration without having to necessarily go from our pH back to hydrogen, or we can go, I'm talking over myself. To go backwards is what I'm trying to say. I'm just getting ahead of myself. To go from pH, guys, back to the H plus concentration is we're just going to take 10 raised to the negative pH. This is where you will use the caret key. All right, so in your notes, next to this, what's that? You can do, yeah, actually, I'm sorry, not the caret key. Second log is what you want to do. I forgot with these calculators. Use the second log function, guys, to do this. It sets it up for you. But make sure you put in the negative for the exponent. Okay, it's a negative pH value. So here we go. We're given pH. We're looking for hydrogen ion concentration. Equals pH, or I'm sorry, 10 to the negative pH. So my H plus is going to look like this when we set it up, and make sure you show all of your work. Negative 7.52. So second log, negative 7.52. That's all you got to plug into your calculator. What do we get for an answer? How many zeros are there? There we go. You can write all the zeros if you want, and I'll count them. If you put it in scientific notation, guys, it's a whole lot easier. What'd you say? And what's my unit here? Is there a unit with this one? Yeah, what is it? Molar, right? Which is concentration. So when you're having a concentration, guys, it's got to have a unit. pH won't have one. So that's the anti or the inverse log is what we're doing there. Okay? So go ahead, guys. I want you to try this problem. Example number 2. Right. So think about it, guys. If you're given pH, what are they giving you first? They're telling you this is kind of a what? What ion are you going to have? Hydrogen ion, the H plus ion, right? So it's kind of like you're given information about an acid. Okay? So we're going to do that first. So H plus equals 10 to the negative pH. All right, so 10 to the negative 3.2. When you plug that in your calculator, what do we get for our hydrogen ion concentration? 6.3 times 10 to the minus 4 is what Garrett gets. Do we agree?
Sure.
All right, so there's molarity. You got to actually do it to agree. If you're just waiting, that's not going to help you out. Then we can use the KW formula to figure out our hydroxide concentration. 1 times 10 to the minus 14 on the top. Remember, you don't have to memorize that. I'm going to give that to you. 6.3 times 10 to the minus 4 on the bottom. What do we get then for our hydroxide ion concentration? Abby. What we've done now is we've shown the first 3 equations, okay? KW, we've shown pH, and we've shown hydrogen ion. Why I say there's 6 equations technically, but really, guys, it's kind of like there's 3, okay? If you look on your gold sheet, like Abby was just saying, she used a different formula, and that's this one right here that I have in green. This is the one that I personally like to use to go between ions. There's 2 formulas, guys, that will let you go between ions and compare those. It's equation 6 and equation 1. All right, equation 6 is pH plus POH equals 14. Have you guys seen this equation before, like in middle school maybe or not? No? Okay. This is the one, guys, instead of using division with scientific notation, it's just taking and subtracting things out or adding things together. All right, that's all you have to do here. Regardless, you have 2 equations that go between ions. Equation 6, and like I said, equation 1, which is the KW formula, where you've got OH minus times H plus equals 1 times 10 to the minus 14. So those ones kind of go together because you have to use one or the other of these equations to get between ions. You can choose which one you want to use. Equation 5 is similar to the equation number 3 that we just learned, where it's the H plus equals 10 to the negative pH. And then obviously equation 4 is like equation 2, where it's going to be the pH equals the negative log of H plus. So depending on what you have, whether you have an acid or a base, it's the same mathematical operations, just noting which ion you're looking at. Okay, depending on what substance you have. So you can use whatever combination of equations you want to solve the problem. You may have 1 step, you may have 2 steps, you may have 3 steps, depending on if you don't want to use KW at all, and you want to just use the pH plus POH, it might be 3 steps. As we go through and do problems from here on out, I'm going to show you both ways, so you can kind of see the game plan as to how I got my answer. You can kind of pick and choose which way you want to go. I want to do one example, and that'll be it, and I'll give you guys your homework to try tonight. So here we go. We're looking for the hydrogen ion concentration of a solution with a POH of 8.2. There are 2 ways that I can solve this. I'm going to show you guys both ways. Here is the first way, and here's going to be the second way. You can choose which way you want to go. So I've got POH. Okay? I need to get to H+. So the first thing I need to do is I need to get to hydrogen. So the first way I'm going to use, guys, I'm going to use equation 6, where I'm going to use the pH plus POH. So if I want to get pH, I can say pH equals 14 minus my POH. You tracking with me so far? All right. If I'm going too fast, say, hey, what are you doing? Okay. All I did, guys, I took this equation, I solved for pH. All right. I took this equation, I solved for pH by subtracting my POH. That's simple math. So pH equals 14 minus 8.2. When you do that, what do you get? 5.8. All right. So now I have my pH, meaning I am in hydrogen now, power of hydrogen. So to get my hydrogen ion, all I have to do is this, 10 to the negative pH. So that's going to be 10 to the negative 5.8. What do I get then for my hydrogen ion concentration when I do that? There's one pathway that I could take. You tracking with me? You've got to find the way that works for you. So there's one way. So first things first, I switched my ions. I went from hydroxide to hydrogen using the pH plus POH formula. Then I went and got my hydrogen ion. The other way, guys, that I can do this, all right, I could take my POH. I can get my hydroxide ion concentration by taking 10 to the negative POH. So 10 to the negative 8.2. Kind of doing what I did here, except I'm doing this part first to just get to my hydroxide ion. Well, when I do that math, what's your hydroxide ion concentration, guys? 10 to the negative 8.2. Somebody do that for me, please. Okay, so that got me my hydroxide ion, guys. Now I can use Kw. So I can use H plus equals 1 times 10 to the minus 14 divided by 6 times 10 to the minus 8. If you do that out, it's going to be the same thing that we got before. So either way that you feel most comfortable with, you've got to find the pathway that you want. Guys, your homework